Hi, welcome back to educator.com in our series on the Java programming language. Today we're going to talk about polymorphism. Now, first of all, we have to define what polymorphism is, because just like with inheritance that we learned last time, polymorphism and inheritance are complicated subjects. They're difficult things to understand, but when we look at the code, we're going to see that it doesn't take a whole lot of code to take advantage and to execute inheritance and polymorphism like it does with if logic and loops. But to understand it and to understand what it's doing, that takes a little bit of thinking. So first of all, let's break it down. Polymorphism, if we break that word down, we can try to decide what it means. Poly, first of all, is a prefix. That means multiple. And morph, in general, means a shape or a form. So if we put the two words together to polymorph, or polymorphism as a noun, polymorphism is something that has the ability to take on more than one shape or form. And when we come to polymorphism in programming, let me give you a couple examples here. So let's say that we have a class and we are going to design a superclass, and we know that we're going to have subclasses that inherit those superclass values. We want this particular superclass to be able to polymorph itself and so that we can reuse the code, but we don't know exactly what all of the parameters are. So we're going to set up our superclass so that we know that later on it's going to take on more than one form. And the first example I'm going to talk about here is, let's say that we're talking about a superclass of animals. So we have a video game that sets up a zoo, or we've got a video game where we've got animal characters, and we know that we're going to have a bunch of animals, but we don't necessarily know all of the animals. And as players start to take on these animal roles, we don't necessarily know which one they're going to choose and what those animals are going to do. So we just say the superclass is animal. Then we get more specific. We say one of these subclasses of animals we want to have as birds. So we don't know what kind of bird it is yet. We just know that some of them are going to be birds. We want several variables in there, like how does the bird move, what does the bird eat, how does the bird sound. And one of those variables is going to be sound. And we want this particular variable with this particular subclass to involve the chirp sound. All right, so let's contrast this now with another animal. Say we want another animal to be a cat. We still want to have that sound variable existing with the cat, but at runtime we want the method not to be the chirp sound. We want the method to be the meow sound. All right, so this cat has polymorphed itself from our original animal superclass. We didn't know what animal was going to be called. We didn't know what sound that animal was going to make. We just know that it's going to be an animal and it's going to have a sound. Same thing with if we have a dog subclass. If we have a dog subclass, we know that that is going to have a sound, and we know that that is going to create the sound of woof or bark. Let's say that we have an animal that doesn't use a sound. Then this variable can just be left blank, or it's not going to be called. So with polymorphism, you've got ultimate flexibility. You can call the method, you cannot call the method. When you call the method, you don't necessarily know what it's going to act like. Now, let me give you another real-world example here. Something a little more in the financial realm here. Let's say that we're working for a bank, and we've got customers, and they have bank accounts. So we set up in our programming that in the superclass we have a bank account. And let's say that this type of bank account could be interest bearing, so it's going to be something like a savings. So it could pay interest or it could charge interest. We don't know. We just know that it's a bank account like a mortgage or it's like a savings. All right, so let's say that in our specific subclass we do have a savings account. That is an interest-bearing account. So whoever opens up a savings account, whatever money they deposit in there, it's going to generate interest income. That interest rate is going to be a variable. And let's say that in the case of a savings account, the interest rate method is going to calculate and generate interest at 2%. Now, let's say that we contrast this with another type of bank account. We might have a money market interest-bearing account. That is also going to use the variable interest rate, but For a money market, they usually pay a little more interest, so there the method is going to calculate and generate interest at 3%. And then we could even use another one. So we say, let's have a CD, a certificate of deposit account. Same thing, that's an interest bearing. That is going to have an interest rate, and that method, let's say, pays out at 4%. And then we might also have a mortgage or a car loan, and that mortgage is going to be charging interest, so the interest rate there is going to use a different method. Let's say that the method is going to charge like a negative 5%. In other words, you are paying that interest, you are not gaining that as income. So here we are having this bank account polymorph itself into different types and different methods of accounts. And at runtime, it's decided, depending on what kind of account the customer opens, it is decided at runtime what the interest rate is going to be. Now, in the folder where you have your program files and you have your Java files and your class files, it's going to look something like this. We might have the bank account class, and that is going to generate all of these others. We might have the savings, we might have the money market, we might have the CD, and we might have a mortgage. And those are all going to be subclasses that are stored here and being inherited from the original superclass bank account. All right, so this concept and process of using polymorphism in conjunction with inheritance, this brings up the subject of abstract classes. All right, so to get polymorphism to work, we have to understand what an abstract class is, and we're going to contrast that with sort of the opposite of the abstract class is what Java will call a concrete class. Most of the classes that we've created so far in our Java lessons have been concrete classes. We set up the class has variables, the class has methods, those methods have parameters, and those are set in stone and they don't change while the program is running. They don't change as you go from one program to the other. The variables might change based on user input, but those methods pretty much stay the same. Here, with polymorphism, we're going to use something called an abstract class to give it more flexibility. So really what an abstract class is, it's a class that doesn't have any objects. So in the past, we might have said we set up a class for animal. One of those classes is going to be a bird. We already know that, and that is a bird, and that bird is going to be an eagle, let's say. So we already know that the eagle is a specific instance of an object within that class. Here, with an abstract class, using the abstract keyword, we're saying we're setting up this abstract class with the idea that we're going to generate more subclasses after this, but we don't know yet what those subclasses are. We don't have any idea if we're going to use it, and if we use it, we don't know what the specific object is going to be. All right, so these abstract classes use polymorphism and inheritance to generate later the specific object and the specific subclasses. So these abstract classes are going to be constructed with methods that are purposefully left undefined. We know that we're going to have a method like, with the animal sound, a sound, but we don't know what that sound is going to be yet. And these methods are going to have information that's going to be provided at runtime, not at compile time. So with a concrete class, all of those things get defined and set in stone when the program is compiled. Then when you run it, it stays the same. Here with an abstract class with polymorphism, at compile time, it's still left as a big question mark. It's a variable. When we run it and say, okay, this one is going to be a bird, this one is going to be a cat, then that information at runtime is set, and as you run the program from instance to instance, that polymorphed class will change, and the variables will change to take on their new definitions. All right, sometimes with these abstract classes, let me give you an example here. You might have multiple methods. And so let's say that we're setting up a video game in this example, and we've got characters, and all of these characters have a certain kind of weapon. And with that weapon, each of these weapons has a method of how to fire the weapon, and whether or not it uses ammunition and whether or not that ammunition runs out. So how many times can you fire the weapon before the weapon goes dead? And what kind of damage does that weapon inflict? All right, so we might have concrete subclasses that are set up, but we've set up our weapon to be an abstract class. So let me show you how this works in conjunction. So the human, let's say, their weapon might be a rifle. And that rifle might have methods of how to fire. The fire is going to use bullets. Those bullets are going to be an ammunition. Let's say that you've got 15 rounds, so you can fire that weapon 15 times with the human. And it is going to inflict 5 damage points on whatever it shoots. All right, let's contrast this with a fantasy role-playing game. Let's say in this game we've also got wizards. That wizard is a concrete class. That wizard, however, is going to call the abstract superclass methods, abstract superclass of weapons and its associated methods. But instead of it being a rifle, with a wizard, it's going to use a magic wand. That is the wizard's principal weapon. The magic wand does not have bullets, but it can be fired, and so we are just going to leave that as it is to be fired, and we're going to say that the number of times that magic wand can be fired is infinite. All right? And the damage points, let's say that it is not a very strong spell or whatever the wizard does, so it only inflicts damage points of 1 point. The wizard mainly uses his weapon as a magic wand to escape situations. So we've set up this polymorphed weapon superclass to have the flexibility to take on these other characteristics. Let's say that we've got a monster. The monster uses its claws and teeth as its weapon. Its fire method is the bite or claw. It can do this, let's say, 10 times. Let's say the monster character can inflict really a lot of damage, but it can't do it that much because then the monster gets tired and it needs to eat or it needs to rest, just like you have in fantasy role-playing games. All right, so it can do it 10 times, but it inflicts double the damage points as opposed to the rifle. So it's very powerful, but it just can't be used as much. So we've got these variables that are being set up here. Let's say that we're playing a role-playing game where you've also got a ship as a weapon. This ship has torpedoes, like a submarine, as its weapons abstract class, and this will cause an explosion. It has, let's say each ship has a number of 2 torpedoes that it can fire, and it is going to inflict a lot of damage points, 20 points. Airplane, same type of thing. Airplane is going to have missiles. The missiles will cause explosions. Let's say that an airplane has 4 separate missiles that it can fire, and that is going to cause 40 damage points. All right, so all of these methods are variable, and they're not going to get called and used until the user hits the fire button on the joystick while you're playing the video game. So when that fire button is hit, depending on what character is active, the polymorphism is going to call that particular weapon, and it's going to keep track of the number of times it's been fired until it reaches its limit, or unless it doesn't have a limit. And then if it hits its target, it's going to inflict its variable damage points. So here you can see polymorphism is very important with video game development and with other real-world programs like with bank accounts. All right, one more concept here with polymorphism, and that is the final keyword. Sometimes you might have a method in your superclass that you do not want to undergo polymorphism. You do not want it to change. You want this superclass method to be more concrete. You want it to be set in stone. So you are going to declare it with the final keyword, and that means that this method cannot be overridden, like we just saw with the video game example of the weapons. That cannot be overridden in extended subclasses. So let's say that we've got another video game role-playing game, and let's say that this is like a World War II type of video game where we've got ships, Navy ships, and Navy planes. Let's say that these vehicles, these ships and planes, have methods that control their movement, and then how fast they're moving, speed, their armament, whether they are heavily armored or weakly armored, and what kind of weapons they have. Let's say that the speed, armament, and weapons subclass methods are going to be abstract. So just like in our previous video game example, a PT boat is going to have more speed than a battleship. A heavy bomber is going to have more armament and different class of weapons than a fighter plane, and so forth. But what we are going to set as final is the movement. The ships are going to use a sailing method, and the planes are going to use a flying method. So depending on where they can go, how fast they get there, whether they're subject to wind or ocean movements, that is going to stay the same. And what this will enable the game to do is to make sure that, logically, ships will not be able to use the fly method and planes will not be able to use the sail method. So those methods are going to be finalized with the final keyword, and then all the rest of the variables can change as you go through polymorphism. All right, so as you see, it's a complicated but very flexible system of being able to run your programs and have all your methods and variables sort of be left open with a question mark. And as things get defined at runtime, then we see things get developed specifically. All right, let's take a look at some examples. Let me open up the text editor. And in this first example, we're going to demonstrate some real basic polymorphism here. And here we're going to have a class of employee. This is going to be our superclass. And this employee, if we call it and run it, it will output the statement, I am an employee. All right, now, within this class, we are going to extend the employee class, and we're going to call this next employee a manager. All right, so this is inheritance. We just said this manager extends the employee class. With this manager subclass now, we say he is not going to say I am an employee. He or she is going to say I started as an employee, but now I am a manager. And then we're also going to have that particular subclass say I manage many employees. So when we run this program, we could run the program as an employee or as a manager. And if we run it as a manager, then the employee information is not going to show up. Only the manager information or output is going to show up. All right, so here we say public static void main statement, and we further define the employee and the manager. And when we run it, we're going to see that the employee information is not called, just the manager information. All right, so let's go to our DOS or command prompt here. And I want to say run the program, run the Java program, poly example. And when I do, you can see that the manager gets called, not the employee, and it gives us that output statement. I started as an employee, but now I'm a manager. I am a manager. I manage many employees. So you can see, even though we started the program with the superclass employee, it underwent polymorphism, and when we ran it at runtime, it gave us the manager information. All right, let me clear this, and let's go on to our next example. All right, here we're going to have a polymorphed superclass with multiple subclasses. In our previous example, it was very simple. It was very basic. We had the employee superclass. We had the manager subclass. We did not have any more subclasses than that manager, even though we could have. We could have had entry-level employees, managers, supervisors, directors, and so on. But we just kept it simple to begin with. Here we're going to have a little more complicated of a setup. And this is going to use animal superclass and specific animal subclasses. And we're going to see if we can have this animal polymorph itself to give us different, at runtime, give us different sounds. All right, so our superclass is animal. And this superclass returns the statement that this is a animal type. We're going to say a bird, a dog, a cat. All right, and then we want this animal to have sounds. So we say we're going to have a void statement saying that this is going to have this class is going to have a sound, And this sound is going to have an output statement so that we can read what sound that animal makes. Notice that we say public void because this is going to be polymorphism. We don't know what sound it's going to be. We are leaving that open. All right, as we scroll down here, we get to our subclasses. All right, so we say that the subclass dog extends or inherits all of the specifics from the animal. And then in this void statement with the sound, we fill now the void with the sound in a print statement that dog will make. We say dogs go woof woof, okay? Then we do the same thing with a cat. Cat extends animal, that's inheritance. We further define name and breed. And then we are going to also return a statement that says a name for that specific animal and whatever kind of animal it is. And in the void for the sound, we output the statement that the cats say meow. So let's contrast this. There's a couple different things happening here with polymorphism. Notice that with the dog, if we scroll up there, we just have an output statement for the sound. We don't have a statement that says this is a dog, or this is, as we're going to see later, this is the name of the dog. This is Prince the dog, or this is Rover the dog. Here with the cat, however, we've got not just that one output statement for the sound, we also have an output statement for the name of the cat and what kind of animal it is. So here we're seeing a variable for not only the sound, but also that the dog does not use the string statement identifying what the name is, and the cat does. All right, so polymorphism not only provides a variable for what the sound is, but whether or not you're going to use one particular output statement. Then we've got our third example here with the duck. And the duck is inherited from the animal. It extends animal. And it is going to use this output statement down here so that it will say that this is a duck, or the name of the duck and what kind of animal it is, and the output statement that we want the quacking statement, okay? All right, then we further define the string of the animal's name and breed. We've got the general public class, superclass animal sounds, and then we've got our public static void main statement here. And then we set up an array. The array sets up the new dog, and that just says that it's going to dog only has one argument constructor. And the cat, however, and the dog have two, so we're going to say it's Morris the cat and Danny the duck. All right, and then when at runtime, when this runs, it is going to pull this information from our array. And depending on what kind of animal it is, it will either pull the name or just what type of animal it is, dog or cat. Then we set up a looping statement so that at random the program will choose what kind of animal it is from the array, and it's going to do that 5 times. When it runs through these loops, it is going to say that the choice is, and then it's going to show what choice was made, what animal was picked, and what sound the animal makes. All right, so we've got inheritance happening in this program, polymorphism, we've got an array, and we've got a for loop. So there's a lot of things going on. So it's a pretty complicated program, but when you see us run it here, you're going to realize that it runs relatively quickly. So let's see what happens. We say Java, and the name of this program is Animal Sounds. All right, notice the output when we run it. Happens relatively quickly, even though it's a long program. It's taking advantage of all those relatively advanced techniques that we've learned. And the first choice that was picked at random is the duck. It gives us the duck output statement. Second choice was the dog. It does not say the name of the dog because we did not have that in the program. It just tells us what the output sound is of the dog. Cat, it says that it's Morris the cat, and the cat says meow. And then at random, it also picked the duck again, and then it picked the duck or the dog again, and then the dog again for the 5th time. All right, let's run this one more time just so you can see it in action. We say we want to run the Java program Animal Sounds, and it runs again. It runs the dog, it runs the cat, it chooses the dog, it chooses the duck, it chooses the dog. So you can see it's choosing the animals at random. Those animals have names. If it's a duck or a cat, it does not have a name if it's a dog, and it makes a different sound each time the animal is called. Here is an example of a polymorphed multiple class, multiple subclass program, and it runs differently because we've called the random function every time we run it. All right, let's go on to our third and last example here. And in this next example, you will see the most complicated system. It is going to have many subclasses. It's going to use inheritance and polymorphism, and it's going to use geometric shapes. All right, so let's take a look at the opening program that has the public static void main statement right away. And this is our testing program, and this testing program is going to call all of the other superclasses and subclasses. So we start by setting up an array here that calls shapes. It's going to have 1, 2, 3, 4, starting with 0 shapes. We're going to say we want a circle, we want a square, a sphere, and a cube. And these are the parameters, the arguments, for each of those particular shapes. So this is going to determine its size, and if it's a three-dimensional shape, it's going to determine its volume. So in this example, we want to be able to generate information on these shapes, and if it's a two-dimensional shape, we want to see its area, and if it's a three-dimensional shape, we want to see its area and its volume. So based on polymorphism, we don't know what shape it's going to be until we run it, and when it runs, we want the shape to be handled accordingly. All right, so here in this opening program, we want to call the method to print the shapes, the name of the shape, and if it's a two-dimensional shape, we've set up our if statement here. So it's going to show the two-dimensional shape's area, and if it's a three-dimensional shape, we want the area to be displayed, and we want the volume to be displayed. So two-dimensional, just area. Three-dimensional, area and volume. So we've got a big variable there. All right, and then we want that system out to print. All right, so that's our basic running program. Now let's see the superclasses and subclasses that this program calls. First, we define a basic shape. We say that this is an abstract class. Notice the keyword abstract here. We're saying we're going to call this class shape, but it's abstract, so we don't know what the shape is going to be, and we don't know what that shape's methods are going to be yet. That is defined later. But first we set up two variables, two private variables for the x and y coordinates of this shape. We have a two-argument constructor. The shape has an x and y integer, and then that particular shape, we use the this statement to define the x and y. Next, we set the x and y coordinates as the integers, and then next we set up our get statements so that we can set and get those coordinates, x and y. Then we have a return statement so that we can show those particular x and y coordinates. All right, so that is just the simple shape. We're saying that shape is going to have x and y coordinates, and that's all we define at this point. Let's go on to our next class. Here, we're going to further define the two-dimensional shape. Again, we set up an abstract class. The two-dimensional shape inherits, by the extend statement, inherits all of the parameters of the original shape, and then we further define in a four-argument constructor here what dimensions those particular shapes are going to have. We set our dimensions, dimension 1, dimension 2. We get our dimensions, dimension 1, dimension 2, for a two-dimensional shape. And then we set up the abstract public class get area for the two-dimensional shape. Notice that we're not setting up or calling volume yet. That's only for three-dimensional shapes. So this is just for two-dimensional shapes. Next here in our program, we have three-dimensional shapes. All right, so here we've got three-dimensional shapes. We set up the abstract class for the three-dimensional shape. It's still extending and inheriting from shape, but now we've got, just like a three-dimensional shape would, instead of just height and width, we've got 3 dimensions for height, width, and depth. All right, so we set our 5-argument constructor here for all of those dimensions, x, y coordinates, and then height, width, and depth. And then similarly, we set and get our dimensions for the 3-dimensional shape. And then as we go down towards the end of the program, we set up abstract methods for get area and get volume. So if a 3-dimensional shape is called, it gets not only the area but the volume. Now we still haven't defined a specific class within these 2-dimensional or 3-dimensional classes. We're going to do that now. Here we're going to define a subclass called circle. This class is not going to be abstract. Notice that we say this class circle extends 2-dimensional shape. So this is going to be a concrete class because we know that it is going to be a specific circle. We set up the x, y coordinates, and we are going to use the variable we call radius. In the overridden methods here, it overrides, and we're going to say we want the name to be circle. We want the get area method now to be overridden with this particular mathematical formula. We want pi to be multiplied by radius again, so that's going to be pi r squared, and it is going to get that radius by calling it. Same thing here with the setting up our radius as an integer, and it is going to get this radius, remember, from our original shape. Let me show you where that's happening again, just to remind you. Back in our shape test original calling program, notice that we set up that array. So you might be asking, well, how does it know what the radius is going to be? It sets up that original shape circle with these parameters for the dimensions, height and width, and the radius. Same thing with all of these other shapes here. So when the circle is called and defined down here, that's where it's getting that information from, that variable information. All right, so then finally it is going to let us know what the radius is, and it's going to show us through our 2-dimensional shape program what the area is. Here, the same thing happens with the square, but the square is not going to use pi. The square is going to use the get side method. Side times side is going to equal the area of the square, and then it is going to return the area in the 2-dimensional shape based on that program, based on that mathematical expression. Now let's contrast this with our 2 3-dimensional objects. In this class, we're going to say, this concrete class, we're going to say it's a cube, and it's going to extend our 3-dimensional shape class. Here it's going to use the constructor. A cube is going to have x, y coordinates and 3 sides because it has height, width, and depth. It is going to return the area based on this get area formula, 6 times side, and it is going to return the volume by saying side cubed, or side times side times side. That'll be the volume of a cube. All right, so you can see how this concrete cube class differs from the square class. Same thing here as we go to our last program example, subclass of sphere. A sphere is going to have not sides, but the radius. And to generate area information on the sphere, we use this return statement, 4 times pi times radius squared. And it is going to use this formula to generate the volume of the sphere. 4 divided by 3 times pi times r cubed. Get radius times itself 3 times. R times r times r, or r cubed. All right, so then that is going to generate the desired information on the sphere. All right, so we've got all of these subclasses. all of these accompanying methods, and when we run the program in our prompt here, you're going to see it's going to all happen relatively quickly. So I don't need to call all of these subclasses. All I need is to call that original testing program, and we call that shape test. I hit enter. It calls all 4 shapes in their subclasses. It calls the circle. It gives us the dimensions. It gives us the radius, and it tells us the area. Calls the square. Side is 10, square's area, 10 times 10 is 100. It has done that calculation. Sphere, the radius is 2. The sphere's area would be 50. The sphere's volume would be 33. And finally, cube. Side is 8 units long. Cube's area is 348, and the cube's volume is 512. So you can see in a split second that original shape class polymorphed itself into either a 2-dimensional or a 3-dimensional shape, and then it polymorphed itself into either a square or a circle if it's 2-dimensional, and a sphere or a cube if it's 3-dimensional. So when you run a program that is taking advantage of inheritance and polymorphism like this, you might not see all of the superclasses and subclasses where it's getting its information. You just see the end result. You just see the end product, like we did here when it ran. All of those subclasses are contained in the Java program, and they're getting called and providing and passing information to each other, but it's all happening like that, and you might not even realize how complicated of a program it is. All right, so that's it for this lesson. Today we've learned about what polymorphism is. We've learned the difference between an abstract class and a concrete class, and how polymorphism takes advantage of an abstract class. And we've learned that an abstract class does not call specific methods until runtime, as opposed to a concrete class where it's all set in stone and it gets defined at compile time. All right, so next we're going to learn a little bit about exception handling, and I thank you for watching educator.com.